Hello, everyone, and welcome to this talk. My name is Udit Paul, and in this presentation, we'll delve into our research focusing on broadband affordability using our curated dataset of ISP plans in the US. Whenever we talk about internet access, we need to look beyond simply the presence or availability of internet. The focus must also be on the quality and affordability of the available internet service. While the quality depends on factors such as speeds, the affordability component depends on the cost of internet subscription. Affordability remains a barrier to internet adoption in the US, as exemplified by a recent study that shows over 10% of the households cited cost as the reason for not having a broadband connection at home. It is important to highlight the ongoing funding efforts aimed at enhancing internet access and adoption in the US. The most prominent example of such an initiative is the $42 billion BEAD program that has been put forward to expand adoption of high-quality internet. It therefore raises the question, what sort of data is required to guide these large-scale funding programs so that they meet their set objectives? A prerequisite to improving internet access is to better understand where access issue exists currently. Historically, FCC released a dataset of broadband availability and quality at the granularity of census block, which can contain hundreds of people. Given its coarse nature, this dataset was inadequate in conducting fine-grained analysis of broadband access. Recognizing the need for more granular data, late last year, FCC launched the new National Broadband Map that provides internet availability and quality information at the finest spatial granularity of street address. However, this map provides no information regarding cost of internet access to understand broadband affordability. Therefore, similar to availability and quality, we require a granular broadband affordability dataset. Our main objective in this work is to develop a tool and curate a fine-grained broadband affordability dataset. To accomplish this, we utilize the publicly accessible ISP wave interfaces. Through this interface, an ISP provides information about the speeds and prices it offers to a street address. To automate the process of interacting with these interfaces, we designed the Broadband Plan Querying Tool, or BQT. BQT emulates the actions of an actual user when engaging with these websites. BQT takes a street address as an input and subsequently provides ISP-offered speeds and prices for that address as the output. Using BQT, we can curate a comprehensive dataset of ISP plan information to then understand broadband affordability. Given that BQT mimics user behavior while interacting with these websites, it needs to overcome several challenges. One of the major challenges is to produce high success rate or hit rate for the addresses BQT queries to extract ISP plan information. To ensure high hit rate, BQT needs to handle various errors that are commonly encountered. Some of the common failures include ISP interface not recognizing an address, an account being already present for the queried address, or an address being part of a multi-dwelling unit or MDU, such as apartment building. There could also be a combination of these failures for an address. Each of these failures require a specific solution. For incorrect address, we incorporate the logic so that BQT chooses an address which closely matches the initially queried address. If the address we entered already has an active ISP subscription, we choose the option of viewing the plans as a new customer, which results in the ISP interface rendering the plans for that address. Finally, for MDUs, we choose an apartment or unit from the possible options that are listed by the ISP interface for a given address. By accounting for these errors, BQT achieves a hit rate exceeding 80% for the ISPs considered in this work. As we simulate authentic user behavior, BQT encounters scalability challenges due to the time it takes to query an address, which can be in the order of seconds. Querying millions of addresses in such sequential manner would therefore require a significant amount of time. To overcome this challenge, we parallelize the process. We leverage Docker containers and simultaneously launch up to 100 Docker instances while querying plans for any particular ISP. This ensures scalability as we are now able to amortize the overall time taken to query these addresses. Furthermore, containerization enhances BQT's portability across various operating systems. Over 6 months, using BQT, we curate the largest broadband affordability dataset in the US. Our dataset spans across 837,000 addresses provided to us by Zillow in 30 metropolitan cities. Importantly, we covered the two types of ISPs that provide fixed broadband services in the US. This includes the four major DSL fiber ISPs, which offer either DSL or fiber services to addresses within a specific geographic area. Our dataset also covers three of the largest cable ISPs in the US. Given that an ISP provides multiple plans to an address, we need to utilize a metric that can capture the value conveyed to an user through a set of plans. Here we can see an example of AT&T providing three distinct download speeds to an address, each costing a certain amount of dollars. For each plan, we calculate the carriage value, which is the ratio of the download speed and price. Essentially, it translates to the megabits a user gets for every dollar they spend when choosing a specific ISP-provided plan. So for this example, it will be 12.5, 7.7, and 5.5 Mbps per dollar for these three plans respectively. Amongst these multiple carriage values, for each address, we select the maximum carriage value or CV. For this example, it will be 12.5 Mbps per dollar. This single value from a set of plans enable us to compare the broadband offerings across different locations and ISPs. We further take the median CV of all the street addresses belonging to a census block group to denote the census block group level CV. Census block group is the fundamental unit of demography consisting of population that the U.S. Census Bureau considers homogeneous in terms of attributes such as household income and age group. This level of aggregation allows us to investigate how cost of broadband plans vary between different demographics. Using our curated dataset and the corresponding CV metric, we can answer various questions that are important for policy decisions. One such question is, how does fiber deployment from a DSL fiber provider affect CV provided by a cable ISP? Our analysis reveals that users in the census block groups can be categorized into one of three distinct scenarios. The first one is of complete cable monopoly, which consists of the block groups where the cable ISP doesn't compete with any other technology and provider. Second scenario is of cable DSL duopoly. These are census block groups where a cable ISP competes with a DSL fiber ISP that only provides DSL technology plans which have very low CV. Finally, the last category comprises of cable fiber duopoly, which includes block groups where the cable provider competes with a higher CV providing fiber technology plans from a DSL fiber provider. We present the case of New Orleans, where AT&T is the DSL fiber provider and Cox is the cable provider. We observe that cable ISP provides similar CV plans to block groups where it operates as a monopoly and where it only has to compete with DSL plans from a DSL fiber provider. However, the cable ISP improves its CV by up to 30% in block groups where it has to compete with a fiber technology plan. This finding illustrates that fiber services play an important role in dictating the overall CV and user gets in a region. A natural question that therefore arises is, who ends up receiving fiber in a city? To answer this, we first obtain the median household income of every block group as reported in the American Community Survey. Based on this income, we group block groups into two categories of high and low income. Subsequently, we calculate the percentage of block groups within each income category that receive DSL and fiber plans. Taking New Orleans as an example once again, we observe that 16% more high-income block groups receive fiber compared to low-income block groups. We observe a similar trend for other ISP-city pairing, with the exception of Frontier. To conclude, in addition to broadband availability and quality, we also require broadband affordability datasets to assess internet access. As there exists no such data, in this work we developed BQT and curated a comprehensive dataset of broadband affordability in the US. We analyzed the curated dataset to reveal crucial trends related to broadband affordability and answer important policy questions. We have made a version of this dataset publicly available to enable further research into this very important and timely topic. Thank you for listening in, and please feel free to ask any question you have now or reach out to me in the future.